Hello, mentors. Welcome to 20 Comics. This is meeting one from Winter. And so the thing is, we'll buy end comics from a special collection of 20. And it's a special sale, so comics are actually picked at random, so you cannot determine. This is the distribution of the comics by language. So there's 10 in English, so half of them. The other half, almost all in Spanish, so 8 of them. And then in Quiliwa, language from Mexico, only 2 of them. So the total is 20. So here's what's going to happen for each mission. So students will be playing. They'll pick some N, which is the number of books that they get. Of course, they can pick 1, but they can also pick 20, no more than 20. Then they'll see if they pass the mission. We'll talk about the missions. If they do, they get 1 point. And if from all the teams, the N was the lowest from all the teams that passed the mission, they get an extra point. If there's a tie, all tie teams that pass the mission get 1 point. So in other words, here's how it goes in scoring. If you fail the mission, you don't get points at all. If you pass the mission, but somebody else beats you, so picks a better N, a slower N, they pick 1 point. And if you passed and nobody else had a lower N from passing teams, you get 2 points. This will be played over 3 rounds, so 3 missions. And these are the missions. So we're buying comics and we want some diversity. So the missions are coding some diversity, representing some goals that we need. So we need to pass the mission. That means buy a lot of books to guarantee it. But the tension of the game or the contrast is that you actually want to lower the end. You want to minimize, you don't want to spend much money. So it's a risk your luck game. And you'll get more points if you succeed and you're the best in succeeding. So this is really interesting because it's not just about computing probabilities or reading data, but it's about making decisions and having risk and tolerance. So you'll see different strategies. The mission that starts, so mission 1 is get at least 2 comics in Spanish. The next mission is get at least 1 comic in Quiliwa. And the last mission is total diversity, so have all 3 languages represented. So when you buy these end comics, at least 1 of each language. Of course, English will be easy, hopefully, but the others not so much. So you want diversity. How much are you going to spend? So here's how it goes in the workflow of the game. And it's how many comics you pick. Remember, this is played by teams, right? So first teams pick the end secretly. They reveal it at the same time. If there are repeated values, that's totally fine. Then we do team simulations, one after another, so they're independent. So they're done just one team, then another team. Doesn't matter who starts. And then the teams that pass get 1 point. And from all the teams that passed, the ones that got the lowest end get 1 extra point. That's how you can get up to 2 points for each mission. Of course, at the end of the game, you'll just add all the points to see who wins. Time management, of course, you can skip 1 mission or do a little less things or speed up. So we'll talk about this in coaching. And also you can read the teaching guide for concrete suggestions on that. I think it's good to start with some warm-up because these missions, like especially mission 1 starts getting 2 comics. So mission 1, it's a way to start and to demo the game, to see all the rules, but also to get some easier math. If you have the mission to get at least 1 comic in Spanish, you could ask the question, what if n equals 1? So that could be a good discussion just for everybody to be in the same page. So n equals 1, what happens? So it's just a typical probability. You have the total equals 20, and you want 1 in Spanish. So the good cases, so good in terms that you will fulfill the mission, it's 8. So you get a decent probability. So 8 out of 20. And then you can discuss with your students that that's the same as 4 out of 10, right? 40%, so on. So you could get into this discussion that if you play this mission, and you can play it quickly, but just without counting points, whoever picks n equals 1 will have just 40% chance of passing. So if they pass, great. But are they going to pass? So then what happens to n equals 2? It's not about computing probabilities, right? So this meeting is not really about computing, but making sense of how they grow or how they increase or decrease, and how are you willing to tolerate risk. So we'll talk more about this. What about n equals 20? You could also ask the other case. That'll be 100%. But teams are going to say, maybe I can pick less than 20 to even guarantee success. And that's going to be talking in other missions. Okay, so let's understand now the workflow of the missions. Let's say this is mission 1 now. We're now playing officially, get at least 2 comics in Spanish. The mentors in the teaching guide, we suggest strongly that they start with n equals 7. Don't show it yet. And team A and team B, now they have to think, okay, I have to buy some comics. Of course, if I buy 20, I'll get the point of the mission for sure, but probably not 2 points, just 1. So they start to think, what should I do, right? Let's say team A is pretty conservative, so they're gonna say, you know what, these 2 comics in Spanish, I'm just gonna go for 10, right? And yeah, so they kind of reason half is in Spanish, almost the other half is in English, so 10, it feels good. Team B, let's say it has more risk, and they pick some n that's not too high. So let's say they just pick n equals 3, really pushing your luck. Then all these values are revealed at the same time. There's probably surprise. Maybe n equals 3, the team B maybe feels that they maybe push their luck match. So we yet don't know, right? And now what happens is team by team, doesn't matter the order, whoever starts, they reveal. So for mission 1, I think it's good that mentors start. So they're gonna pick 7 tokens, sorry. So this cup is filled with these tokens, color-coded, representing the different languages of the comics. So we'll use tokens in the meeting. And let's say that they pick 7, so they could just count and draw them at the same time. So let me show you. You could do something like this. 1, 2, 3, 4, 5, 6, 7. I'm just pretending I did it randomly. And do this, right? To show everyone. Or for more drama, and especially if n is not too big, they could go 1 by 1. And it's more dramatic because you want 2 comics in Spanish, so 1, 2, 3, so they're like a little worried. 4, okay, they're happy now. 5, 6, and then 7. So the last draw, right, of these 7 saved the day. So they're both equivalent, doesn't really matter. You can use either way. Let's say that was the thing with n equals 7, and let's say that they pass. Let's say in this simulation, they just passed. So now what happens is just that this cup is given to another team. Let's say team A. And again, team A, let's say, randomly draws 10. So 1, 2, 3, 4, 5, 6, getting a little nervous, but maybe 7, okay, that's good. At this point, they can stop drawing, or they can just officially draw up to 10. That's okay. Okay, so let's say they passed. They passed the game, this round, this mission. At this point, they're not going to get 2 points, but just one, because team C, the mentors, pass with a lower value of n. And now team B is the more dramatic now, right? Because they just have a shot at getting 2 books in Spanish. What would happen if they win? Well, let's say they start really bad, but somehow very, very lucky they get, and boom, they passed. The points would be like this. Since everybody passed, everybody gets 1 point, but the lowest n gets 1 more. So this team B would actually get 2 points in that round. So that's the simulation. Of course, I think, yeah, it's maybe more likely here that they wouldn't pass. They would get 0 points. They would get eliminated. So that's how the mission goes. What happens after the mission? Well, now there's some mathematical reasoning, not with probability, but with worst case scenario. We also call it pigeonhole principle in math. So you can read about it also in the teaching guide. But so what happens is students find the smallest n that guarantees that the mission is accomplished, and the reason why. Let's take a look in more detail. So you're asking and discussing with your students how we can guarantee that the mission, right, it's successful. We have all the money in the world. We don't care. We just want to be successful. Some may say n equals 10 because, I mean, it's pretty likely. But then with reasoning and with other students that say, it's still risky, still not 100%. So this doesn't work. Some students will say, well, let's just buy all 20. So I'll get actually 8 books in Spanish, not just 2. So of course I'll pass the mission. So this is so-so. It's getting on the right track, but it's not the least n. So that's the question: what's the least n? And so it's a reasoning about what's the worst we could do. So if we have all the bad luck in the world, if we're just really, really unlucky, is that you just get English a lot, so 10, the first draws. And then after you think you have good luck, you get in this other language. So remember the 3 languages, just so English, Spanish, and Kiliwa. So in Kiliwa, you get the other 2. So that's really bad. So far, 12 runs. But now, okay, I ran out of bad luck because everything else now it's in Spanish as far as the comics. So I would have to just put Spanish 2. So if I add 10 plus 2 plus 2, right? 10 plus 2 plus 2, I'll get 14. So actually 14 is the answer to this question. It's the least n that satisfies that I will succeed the mission. Does it mean that it's the best strategy to play? Not necessarily. Does it mean that I'll always get 1 point? Yes, that's if you always want to get 1 point, no matter how many rounds you play of the same mission. If you pick n equals 14, you'll be good. And it's a good minimization because you may be able actually to win the game getting 2 points. So it's a good strategy, but we can also discuss with students if this n represents the best strategy. And now there's a new mathematical concept called, you don't have to talk it to your students, but that we understand it in coaching, marginal. The concept of marginal, right, comes from margins or really, really small, right? Which means that if you play n equals 13, no longer 100%, but pretty close. Okay, so hopefully students will get that intuition, knowing that this was really worst case scenario. This was just a stage that it was really unlikely, right, to get to that, but close. So then they'll see why maybe playing n equals 11 or n equals 10, something like that, maybe a pretty good strategy, even a little less or so. Students may be curious and say, but what are the really the probabilities? So we go to the next stage to discuss the probability close to 80% question. So what's that question? Let's put it here. What's the best n to pick if I want close to 80% chance of passing the mission? It connects naturally with this question because this was 100%, right? So they won't be calculating abstractly these probabilities, but they will experiment. So they pick some n, let's say they pick n equals 7, and they experiment, meaning taking the cup, drawing 7, seeing if they pass or not, and doing this experiment all over again, like maybe 10 times, 15 times, however they want it, and just recording how many times, what was the proportion of times that they passed. So this is not a proof, right? It's not the theoretical probability, but it's an experimental way. We'll move into, more about this in meeting 2 when we'll actually show them some probabilities and they can make sense of that. So this is just a teaser. Again, if you don't have time for in some missions to do this, then you can stop at this worst case scenario mission. So that's the game. Let's quickly review the missions. Mission 2 would be get at least one comic in Kiliwa. So you could, again, do n equals 1. This goes back to this mission. But so if we change it to, so this would be mission 2 in Kiliwa. Now good is just 2, right? So 2 out of 20 is just 10%. So playing just n equals 1 is really risky, just 10%. So it's interesting how students will have intuition about how much more n they want to, right? They want to add. How much they want to increase the n. They know that once they get to 20, that's 100% or even below, right? Here, the worst case scenario would be 19. But then what do we pick? What's the best strategy for games? So that's where the probability comes. And this meeting is really about, or this part of the meeting is really about the distinction between likely and certain, right? 100%, I'm totally sure with this worst case scenario versus I played the game and I took some risks. Did I take the good risks or was I really too risky or not? And experience, right, teaches you that. Okay, so hope you have a lot of fun in the meeting. Enjoy and see you in another video. Goodbye.